Today, we are talking about motion, a topic that requires scientific devotion. In physics, it's a concept that's really key. An outstanding topic, just wait and see. Force and friction can set things in motion, as well as gravity, as you see with the ocean. In a vacuum, things will move until there is an attraction. When two forces meet, there's an equal and opposite reaction. With motion, there are many different themes. Each piece of the puzzle works together like a team. Projectile, circular, random, and isolation will help you understand through this rhyming explanation.
Isaac Newton is the man with the plan. People who love motion are the biggest fans. He begins his studies with 3 simple rules. They're every physics teacher's favorite handbook in school. First, an object at rest will stay at rest. Later, we'll see if you can follow it with a test. An object that's moving will keep on moving. These rules are followed as Newton's proving. Both will happen unless there is an outside force acting on the objects, unbalanced of course. Acceleration happens when a force acts on a mass, like when a foot kicks a soccer ball in the grass. The greater the mass, the greater the force used. With a bowling ball, you'd need more force and your toe would be bruised. Third, for every action, there is an equal and opposite reaction. You see this all the time in every interaction. Newton's laws of motion changed physics forever. A smart English man, he was very clever. His scientific findings set up a solid foundation for scientists everywhere, across every nation.
Let's talk about motion in the form of projectile. It's thrown across the air in a catapult style. Projectile motion moves along curved path under the action of gravity, just like parabolic water trajectory. Acceleration is crucial to the process. Let's be more detailed about this broadness. Acceleration is the rate at which velocity is changing. You can calculate acceleration by dividing the change of velocity. That's blazing. Acceleration of a projectile is 9.8 meters per second squared down, like an object that is thrown across town. Vertical velocity of a projectile is 0 at top of its flight. It looks like it's stopping in mid-air, but not quite.
Kinetic energy is when something is moving, like on the dance floor when we're dancing and grooving. The equation is half mass times velocity squared. The math here is simple, don't be scared. For example, here's an object with a 6-gram mass. Take half of that like we do in physics class. It has 20 meters per second for its velocity. Doesn't its energy strike your curiosity? Half of 6 is 3 times 20 times itself. After all that math, we got 1200 on the shelf. Kinetic energy has units that are joules. If we need to know about motion, just use these tools. James Prescott Joule dubbed the name of this subject. History is important, so give the guy his respect. Kinetic energy is a scalar quantity, not vector. It only has magnitude, we don't need a director. With kinetic energy, lots of work is done, like when you swim in a pool or go on a run. There are many kinds of energy, including vibrational. When the object shakes, kinetic energy creates. Translational happens when the energy moves from one point to another, as the laws of physics prove. Rotational energy occurs when we spin around in place. It can rotate on an axis like the Earth in space.
Potential energy, now that's a different story, thanks to William Röntgen and his scientific glory. This energy is not in motion, but it's ready to be used, like a car that's in park, getting ready to cruise. An example is an object at an elevated position. Its energy is stored until force acts as a condition. The formula here is mass times gravity times height, like what is stored when we are flying a kite. For example, there's a rock held up in my hand. with a 10-gram mass and 7 feet from the land. 7 times 10 times 9.8 gives us 686 joules, which is great. Gravitational and elastic are two different kinds. Let's take a look and see these concepts defined. Gravitational pulls an object towards the planet. 9.8 meters per second squared is gravity's constant. To arrive at an answer, mass is what we need, multiplied by gravity, weight's what we need to succeed. The higher the object, the more gravitational joules. This concept is easy, just follow the rules. Elastic potential energy is our next stop. On the journey of learning, let's take it from the top. This happens when objects are stretched and compressed, like a rubber band shot to its target success. An example is a trampoline when we jump really high. The surface is stretched, but why? This is due to the force put on our feet. When we hit the surface, the process is complete.
In physics, circular motion is a movement of an object along circumference. It's like life revolving around the same circle. For circular motion, we have two types of motion, which are rational speed and rotation/revolution. Circular motion is when an object goes around. It moves in a circle like a car driving around town. The movement of the object is at a constant speed. Trigonometry is what we need. To the circle, the object moves tangent. The way this math works is really brilliant. Here are two examples of circular motion, like stones that are tied to ropes and being swung in circles. A car turning through a curve on a racetrack. Can you picture it? That's kind of whack. Object's velocity vector is constantly changing direction. The moving object is undergoing the acceleration by centripetal force in the direction of the center of rotation. Without this acceleration, the object would move in a straight line. That's according to Newton's law of motion. That's it, everybody. This is our solution. Let's end the show with our scientific conclusion.